Okay, so last time we met, we talked about area of rectangles, squares, parallelograms, and triangles. Just to refresh ourselves, here's the formulas for square. I'll draw and rectangle, so I'll draw some examples. There's a square, there's a taller rectangle. For parallelogram, we discovered that it was the same formula. Remember what a parallelogram looks like. Okay. Slanted, quadrilateral. Okay. Kind of a slanted rectangle. Right. And then we had area of a triangle, which was, area was 1/2 times the base times the height. Again, remember triangles have 3 sides. We also have obtuse ones as well. So today we're going to talk about area of trapezoids, rhombuses, and kites. The first one we're going to start with is the area of a trapezoid. Okay. What does a trapezoid look like? Most of you guys will remember trapezoids looking like this. Sometimes we'll see trapezoids that look like this. Most important thing to remember is that they have a pair of parallel sides. Now, remember that doesn't always get marked, but in general, you can usually try to estimate the shape. So, a couple things to know about a trapezoid. A trapezoid has 2 bases. So let's look at trapezoid number 1. It has 2 bases. Okay? The bases are always the parallel sides. So here's base 1, here's base 2. Now I could have just as easily labeled the top base 1 and the bottom base 2. Doesn't matter, as long as the bases are the parallel sides. Now, the height is always the perpendicular line segment to both the bases. So here's the height for the first one. Here's the height for the second one. Now the height could be the side as well. So if this was a right trapezoid, here's where the height could be. What is the formula for area of a trapezoid? Area of trapezoid is 1/2 times the height of the trapezoid times the sum of the 2 bases. And we're going to go over why that is the case. So let's take a look at some examples here. So we're looking at the first trapezoid. And what I'm going to do, here's trapezoid number 1, trapezoid number 2. I'm going to label the bases and the height. So base 1, base 2. And we're going to do what we've been consistently doing with triangle and parallelogram. We're going to cut this trapezoid into something that we know. Okay? And where I'm going to make the cut here is I'm going to cut half the height. So that would appear right here. So the height was 4. I'm going to cut it at 2, which would then give me the quadrilateral like this. And I can take that quadrilateral, flip it around, and reconnect it to the bottom portion. And you'll see here, I'm going to get a parallelogram. And the base of the parallelogram is the base of trapezoid, the first trapezoid, its first base, plus, and you can see here, this is the second base. And what's the height of this parallelogram? It's half the height of the trapezoid. Okay. So you can see here, the height of this parallelogram is 2. So area equals 1/2 the height times the sum of the bases. And just to show you again, we'll do it with another trapezoid. So we take a look at this second trapezoid. I'm going to label the bases. So here's base 2. And I'm going to erase this base 1 here so we don't get confused. And here's base 1. Here's the height. And the height is 5, so that means that the cut point is going to happen at 2.5. So right about there. And so I'm going to get this quadrilateral. I'm going to take it and rotate it and connect it back with the other side. So the area didn't change, it just changed its shape. It didn't change its quantity. We didn't add more area or lose any area. And we get a parallelogram, which we know is area of base times height. And the base of that parallelogram is the sum of the bases of the trapezoid. So base 1 plus base 2. And the height of that parallelogram is half the height of the trapezoid. And there's our formula. Let's take a look at area of rhombus and kite. Right. So a rhombus, if you guys remember, is a quadrilateral that only has 4 equal sides. Okay. And usually they're slanted. Okay. Kind of like a parallelogram. It's like a mix between a parallelogram and a square. A kite, I'm going to have to hand draw this one, is just kind of looks like what we would imagine a kite usually looks like. Okay. Something like this. Usually you'll see markings to denote that it's a kite. Okay. And we can see markings here for rhombus. Now, the area formula for rhombus and kite is 1/2 times the diagonal 1 times diagonal 2. Where are those diagonals? Well, if I look back at this rhombus, here's diagonal 1. Here's diagonal 2. If I look at the kite, here's diagonal 1. Here's diagonal 2. So you want to remember where those locations are for the diagonals. Why is that the case? Well, let's take a look at a kite here. I'm going to draw in diagonal 1 and diagonal 2. So here's diagonal 1. I'll draw an arrow. Remind yourself, diagonal 1. And here is diagonal 2. I'll use a different color here. I'll use black. So we need to change this kite into something a little bit more familiar, like a rectangle or a parallelogram. If we cut along diagonal 2, we're going to create 2 triangles. And here's what one of them will look like. And if I take that triangle and I rotate it, and I'm going to flip it, and I reconnect it to the other triangle, I'm going to get a parallelogram. And that parallelogram will have the same base as its base will be diagonal 2. And its height is half diagonal 1. So the area equals 1/2 diagonal 1 times diagonal 2. Right? Because this side right here, that's diagonal 2, so is this side. Okay. And the height here, you can see, is 6, half of that is 3. You can see that that's the height of the parallelogram. All right.